as software professionals, like we are trying to deal with complexity every day. Right? We try to keep complexity in control because if things get complex, our everyday life becomes difficult, right? So we are always on lookout for patterns or techniques which can help us keep the complexity low, right? Be it at the code level or at the architecture level. Right? So a layered architecture pattern is one such technique or design pattern which can help us manage the complexity in our applications. Let's start with a funny quote. Does anybody know who Corey House is? Anybody from React world? Okay, cool. Yeah, so before we move further, I want to credit this book, Domain Driven Design by Eric Evans. The content of this talk is borrowed and inspired by this book. Okay, let's begin by understanding what is a layered architecture pattern. So it's a design pattern to manage application complexity. And the way it does this is by defining layers with distinct responsibilities where we can organize the application behavior in these separate layers. So there are four primary layers in the layered architecture pattern. Let's have a look at these layers first, and then we will understand the purpose of each layer. The topmost layer is the presentation layer, followed by application layer. Then comes domain layer. And then finally, we have the infrastructure layer. So these are the layers from top to bottom. Let us now understand the purpose of each of these layers. The presentation layer is responsible for showing information to the user and also accepting user inputs and commands. The application layer is responsible for coordinating application use cases. When we say use cases, it could be things like transferring money or ordering food. These are different use cases applications support, different kinds of applications. And application layer is primarily responsible for that whole use case or user journey. Right. Now, the primary thing that application layer does is it orchestrates between the infrastructure layer as well as the domain layer. Domain layer is responsible for handling all the business logic. An infrastructure layer is basically to provide generic capabilities to all the other layers. For example, things like making network calls or saving information to database or sending notifications. Things like common utility services are provided by the infrastructure layer, which can be used by higher layers. Now, the distinction between application layer and domain layer is not very clear sometimes. The presentation layer is straightforward, like all of us understand that it is user-facing layer. Infrastructure layer is also easy to understand because it is more around utilities and it deals with infrastructure-related concerns. But when you look at application layer and domain layer, even looking at the definition, it might not have been very clear as to what is the finer difference, right? So to explain that, let's look at an example. So we spoke about use cases and application layer being uh, responsible for orchestrating use cases. Here we have a use case which says we need to notify a user about uh, their eligibility for a new credit card, right? So say this is our use case. This would be a concern which the application layer would manage, but it cannot do it alone. In order to fulfill that use case, it has to depend on the domain layer to first determine whether the user is eligible for the new credit card or not. So that logic would be in the domain layer. And then in infrastructure layer, we could have things like notifying the user using push notification or email, right? Infrastructure layer can expose all these different capabilities. An application layer can decide whether it wants to notify through both channels, one channel, or anything, right? So that will be the application layer responsibility. So basically, application layer will rely on domain layer to and infrastructure layer to fulfill this use case. So application layer is here. You can see that it is playing the orchestrator role, right? It is using the other layers to fulfill the application use case. Any questions on this? This is what explains the distinction between the layers, and it will get more clear as we go forward and look at code. But any questions on this? Clear? Okay. So we have looked at the four layers. We have looked at their responsibilities, but because all of this has to sit in one code base, say you are having a backend application, you would probably have all these layers. And these layers need to talk to each other. Now, there are certain rules that are defined for communications between these layers. The layered architecture says that higher layers can talk to lower layers, or higher layers can talk to other classes in the same layer, but lower layer cannot directly reference a higher layer, right? So if you have when we say higher lower here, relate it back to the four layers from the top down we said, right? Presentation, application, domain, and infrastructure. So that was the top down thing. And here when we say higher layer, we are talking about anything which is higher in that four layer structure. So lower layer will not have a direct dependency on the higher layer. That is rule number one. But higher layers can talk to lower layers, or they can talk to other classes in the same layer. Rule number two is if a lower layer has to communicate back to higher layer, right? It can do that through asynchronous means. So we can have observer pattern, or we can have callbacks, which basically avoids a direct coupling between the two. However, lower layer can respond to a direct method call from higher layer, right? So that is synchronous. That can happen. But if imagine if lower layer has to, there is an asynchronous thing, and say higher layer is calling lower layer, and the job is moving to background. It is async, and then when the job is done, the lower layer needs to notify the higher layer the job is done. So that will be done through callbacks instead of direct reference. The whole idea behind this strategy or rules that we are framing is to reduce coupling. Right? We don't want both ways coupling. The third rule is domain layer should not depend on infrastructure layer. We want to keep domain layer separate from infrastructure concerns, and we have already identified application layer as the orchestrator to do the coordination between domain layer as well as the infrastructure layer. So we leave that concern to application layer, and we don't allow coupling between the domain and infrastructure layer directly. This is again in the interest of keeping coupling low. Any questions so far in terms of communication rules between layers. Okay. So we are done with the theoretical aspects of it. This was all that was there for us to learn about the topic. Now we'll start applying, right? So let's consider an example where we have to do fund transfer or money transfer between two accounts. If that is the scenario that we have, how do we now take that and divide that behavior between the different layers in our application? So let's look at that example. We spoke about the four layers. You can see the four layers on top. We have the presentation layer, application layer, domain layer, and infrastructure layer. If we had to look at the classes which can be there for fulfilling this scenario that we discussed of fund transfer, we may have some controller class, right? We can probably call it transactions controller. We may have a transaction service in application layer. In the domain layer, we may have a fund transfer service. We may have account object, which is maybe the source account from where we want to debit the money. Another account object to which we want to credit the money. And in the infrastructure layer, we may have account repository class and also a transaction manager. Let us look at how the flow will be, how we will divide that desired behavior between these classes. So say a transaction controller exposes an endpoint which allows a consumer to do this fund transfer between the two accounts. When that endpoint is invoked, transactions controller can pass on the account numbers and the amount to be exchanged to the transaction service. That's the first step after controller receives the request. When transaction service is called for the transfer, the first thing it would do is it needs to create a transaction. Can anybody tell why it needs a transaction here? A database transaction. Exactly. So debiting and crediting is an operation that will happen over two different objects, account one and account two, and we will save them separately. So if one save succeeds and the other fails, we have to roll back, right? So that is why we need a transaction manager. And it's the applications layer's responsibility to handle the transaction management and transaction lifecycle. The application layer is also responsible for fetching the accounts for the given account number. So we will get account numbers in the request, but you need the actual account objects from the database. The application layer and the transaction service in the application layer will be responsible for fetching these accounts from the account repository. So it will pass on the account numbers and get the accounts objects. Once it has these account objects, it can invoke a method in fund transfer service which can accept the account objects, which are domain layer objects. We have the accounts. And then it can go on with the domain related logic. So at this point, this transaction service, which is in the application layer, will delegate to domain layer. So far, it was delegating to infrastructure layer to get to get the entities. And then now it is starting to delegate to the domain layer. Once fund transfer service in the domain layer receives this transfer request, it can perform a debit on account 1 for the amount to be exchanged. It can issue that instruction to the account object, which is in the same domain layer. When account object receives that $100 debit, it needs to first check whether it has the balance, right? And if the balance is there, it can perform the debit. Subsequently, the fund transfer service can issue a credit instruction to the recipient account. As an example, the recipient account can check whether it is active, right? The same check will apply to the other account also, but just for illustration purposes, I have shown difference here. So the recipient account can check whether it is active or not, and then accept the credit. So that ends the domain related logic. The domain logic was only about performing the debit and credit. So that was all managed by the domain layer. Subsequently, the transaction service can save the accounts in their updated status now, and finally commit the transaction. Now you may ask any questions first before I go further. Not necessarily. So if you have classes in the same package, you can still call them. You can still have a directional relationship between them. So there was a question from the audience. If classes in higher layer call each other or reference each other, will it cause a circular dependency? The answer is you can manage it in a way where you still have a directional relationship within the same layer. Unidirectional instead of bidirectional. So you would have seen you design packages and packages have related classes, right? So they talk to each other to fulfill a particular functionality. So they are technically in the same layer in a package. If we are talking about Java in object-oriented terminology or languages, Java or .NET, you will have a package, it will have a bunch of related classes and they will work together. They will have references to each other and they will fulfill one functionality as a module. So same way we can manage a layer also. So that's the answer. There is one more question. Can we also say like domain layer is also the business layer because we do business calculations here? That is correct. Domain layer is actually the business layers. It is responsible for all the business logic. That's exactly the purpose. Any questions? Good? Getting so far? Okay. Now we may wonder why have this fund transfer service in the domain layer additionally, right? Can transaction service not directly issue the debit instruction to account 1 and account 2? Fair question. Why create an additional abstraction? Now, yeah, technically application layer coordinates with domain layer object. So there is nothing wrong in technical feasibility of the transaction service from application layer directly issuing a debit instruction to account 1 and credit instruction to account 2. But the thing is, there is a business rule hidden there. So the debit should succeed and the credit should also succeed. When both succeed is when the whole transaction is successful, right? Now, if you move this responsibility to transaction service, then it will have to do that. The business rule will leak there. It can issue the debit instruction, it can issue the credit instruction, but it'll have to reconcile that both of them have succeeded. That reconciliation bit will end up being in the application layer, which is actually a domain logic, right? In the sense that debit succeeded and credit succeeded, that is when the whole transaction succeeds, is domain logic. It is not application logic. That is why although technically application layer can call domain objects, domain layer objects, to avoid that business rule leakage is why we have this another layer of fund transfer service acting and taking on that additional responsibility to keep the domain responsibilities within the domain layer. The distinction is clear. We will see this in the code also, and that will become slightly more clearer. There is a question. Business logic is spread across both application and domain layer because I see application layer to be the layer that knows how to perform a business operation of money transaction. Uh, well, actually, not really how, but it knows whom to delegate to. It does not know how to perform the transaction, but it knows how to use the domain layer to perform the transaction. That's how I would put it. And obviously, for the whole functionality to work, the classes in each layer will have to work with other layers. Now, there are some rules, as we saw, that there can't be direct dependencies and between certain layers, and those rules apply. But overall, the classes will need to work with each other so that the functionality can be fulfilled. Moving on, let us look at some code. So there is this GitHub repository. It's public. Go back to that once. Okay. Anyways. Yeah, so I have created this public GitHub repository. If you can refer to it after the talk if you want. But we have tried to take that use case and write the code that we just saw in picture. Now that is translated into code. Can you see? It's visible? Okay. The right side, if I increase the right side or the left side. Okay, I'll try to do the right side. How about now? Okay. So if you see, we saw the four layers, right? Presentation, application, domain, and infrastructure. So in the code, for the same use case that we saw of money transfer, we have these four layers. We have the presentation layer as one package, and within this there can be sub packages. This is a Java Spring Boot application. In the there is an infrastructure package, there is a domain package, and there is an application package, each corresponding to the four layers we saw. We will start with presentation, which is the controller. So we have a transactions controller, which we saw. It has a post endpoint. And it has a dependency on the application layer. The transaction service is in the application layer. So that is a dependency in the controller layer, which is the presentation layer. We receive the request. We have a DTO for that called transaction request. It has account IDs and amount to be transferred. We receive the request and we then delegate to the application layer service. called transaction service to do the fund transfer. We give the account IDs, source, destination, account ID, and amount. If the request succeeds, we send OK. If it fails, we send bad request. Okay. So this is the presentation layer. We will move to the application layer now. We have only one class here, transaction service. That depends on, if we go to the diagram, okay, for some reason that is not coming up, but okay, I will keep it like this. So we have the application layer. So we saw the first interaction. Now in transaction service, we have a dependency. We should have a dependency to account repository, transaction manager, and fund transfer service, because those are the three arrows originating from that layer to the lower layers. We do have a dependency to account repository. We do have, so this is an infrastructure layer dependency. This is a domain layer dependency, the fund transfer service. For transaction, we are not using transaction manager. We are using Spring Boot annotation for managing that. So that's why that dependency is not explicitly injected. Here, if you see, it will basically fetch the accounts using the repository, because only application layer interacts with the infrastructure layer. So it will fetch the accounts, and then it will delegate to the fund transfer service with domain objects, right? So we have accounts, account source account and destination account objects, which are from the domain layer, and we have the amount. So we have this and this.
One quick question, right? So we are getting this get reference ID, account repository get reference ID. That means we are, this is a application layer. Are we in application layer? Yes.
This is an application layer. Yes.
And so I can see the repository that get reference ID. So they are calling directly the repository.
Exactly. So application layer can talk to the infrastructure layer. Domain only should not talk to infrastructure. Domain should be independent. Domain can be called by application, but domain will only have business logic and be orchestrated by application. So application will use domain object. Exactly.
Can communicate to anything, but domain should not be communicated to.
Yeah. The domain layer we want to keep as isolated from all the other dependencies, especially infrastructure. We don't want to couple that. Now, so it is getting these two objects, and here it is delegating to the domain layer fund transfer service. We will see what is there in that. In the domain layer, we have few classes. We have the account class, which has attributes like ID, customer ID, account status, account type, balance, and some bare minimum attributes just for demonstration purposes. Account status is active, inactive, all of that. Account type, we have different types of account. So all of this is domain logic. See the distinction. We also have defined minimum balance rules, which are domain rules in the enum itself. You can define it in a class, but it was simple enough use case. So we have created an enum with minimum balance value tied to the account itself. And all of this is in the domain layer and the primary transfer service. So what we will do, what this layer will do is it will further use the account, source account and destination account an issue with credit debit instruction, right? And then, so this is the key bit. Like if we don't have this service, this line of logic, right, whether both deposit and withdrawal should succeed for the transaction to succeed, this will leak into application layer. But this is a domain rule. This last line that I'm highlighting, right, both credit and debit succeeded, then only transaction succeeds, is the domain layer rule. So if we don't have this fund transfer service, this last rule will leak into application layer. That's why we have put this. Let's quickly look at what is there in the account class. So we had these attributes, but it has other things also. On the withdraw instruction, we obviously check the account active status. So the account domain object has all the necessary information for all this logic to reside within. So we won't leak all this into service layer and all of that, right? So domain objects are supposed to be behavior rich. They are not supposed to be only data containers. So what we have done here is when an account is receiving withdrawal message or instruction, we will check whether the account is active. The account can tell whether it is active. The account can also check minimum balance because it knows what type it is. And we have minimum balance already baked into the account type. So it will check whether it can withdraw. So there is a simple method here which says whatever you are asking me to withdraw, I will minus it from the balance and compare it to the minimum balance of the account type. And if it is greater than 0, I will allow. So that will tell whether withdrawal can happen. If both of these are fine, then we will go ahead and remove the debit the amount and say successful. If any of these rules fail, these are all business rules, right? The business will say if account is inactive, you cannot withdraw. So these are all domain rules, business logic. So that's why it is in the domain layer. That too, not in a service. We have moved it closer to where the state itself is. Now, so that is the withdrawal conditions. When we get a deposit instruction, we'll just check whether it is active. We'll add the amount and return true. And both of these return true. Fund transfer service will do the check that both of them succeeded and then respond back to the application layer, which is orchestrating. So it will check whether the domain layer confirmed the transfer successfully. If it is successful, it will return true. It will save the accounts because it has updated the balances. Now saving will be again application layer responsibility. And we have the transaction logic, all of that here. So it will perform the save, it will return success. And finally, the presentation layer will see whether it was successful and depending on that, return a response to the API. Any questions so far? Yeah. Any reason? So there is a question. Any reason for naming domain files with the same suffix as service instead of domain for clear segregation? There is no recommended convention to have to add a suffix like this is a presentation layer class or this is a domain layer class. In fact, if you go further into, so we have looked at domain layer, right? If you go further into this and if you read about domain driven design, it will tell you what are the different kinds of objects which can be there in the domains. So far we saw account type, etc. Those are entities, but then domain driven design, if you go more into depth, there are different kinds of uh, objects that can be in the domain layer. Together they make up the domain model, which encompasses all the business logic of the domain. What we saw was just an entity because this example is simple, but you can also have service classes in the domain layer. We have fund transfer service also, right? So technically service classes can be there, entities can be there, value objects can be there. These are all terms you will know if you go more in depth of domain driven design. Okay, so this was the code bit. I hope it was clear. I'll pass the mic. The retry logic is application behavior. Application behavior.
But then it'll be the retry logic I was asking. So the if it is in the application layer, it'll again be the domain logic, right? Because it is failed and individually it has failed, I have to retry. Is that not the business logic?
Individually, which one has failed?
If it DB saves.
Right. See, the whole thing about why the domain layer is actually encompassing rule not only of software, even if you do it without software, if you do it on paper also physically, the rules remain the same. Right? So there would be no retry concept when you're doing this whole thing on a physical ledger. Right? Software is a digital version of real world. Right? So the rules in the domain layer correspond to the real world. Right? Whatever you try to do in the software generally will on top of what happens in the physical world, that will generally come into the application layer. Things like retries, things like sending notification when a debit happens. We will see some examples of where each thing falls further. But know the distinction that what remains in the domain layer is something which will exist even if we don't have a software version for the domain. That is a good way to judge. Distinction is clear?
Communicate with the infrastructure layer, because once the domain logic is success, the success message is returning to the application layer, and then application layer is giving a final request to infrastructure, right?
Yes.
So why not domain should send the final? I mean, once everything is done and after the success message, why not we get the success message from the infrastructure layer to application layer?
Infrastructure layer can tell you whether the DB operation succeeded. It does not even know we are dealing with account. It knows it has an object. Right? It can be an account object, it can be an order object, anything. Infrastructure will say db.save successful, entity is saved successfully. It does not know whether these two accounts need to be reconciled, whether both the saves should succeed, right? Those things are, in this case, that debit should succeed, the save should succeed, the save for both objects should succeed, is a responsibility of the application layer, right? Because it is about managing technical complexity, right? About the saving part. Because we are in software, we are implementing it as software, we have that challenge. If we are doing it physically, you won't have that challenge, right? On paper, like how we used to do before, right? So there would not be a concept of database failure and all, right? So that is where you need to see what is applicable if you are implementing this without software. That is in domain. That should be in domain layer, right? But any technical things which come as a side effect of you implementing the domain into software are all application layer concerns.
Okay, my doubt is, see, the transfer is happening in the domain layer. I mean, the success message is happening in domain layer. Finally, we are sending the save message to infrastructure. What happens if there is a fail when sending from application layer to infrastructure? So the domain has done succeeded, but still DB has final saving is not been succeeded, right? So how come we can show to the presentation layer that transaction has been done proper?
So the domain is succeeded only in memory because we are in software thing. But if you don't save, it is not complete from a software perspective. If you were working in a physical thing, you would make an entry in your ledger saying debit and credit, and it will all be fine. But here, even if so, firstly, this kind of failure would happen when the service crashes right at that moment when it was about to return, right? Yeah. Now, even if that happens, nothing got saved into the database. So that thing was never committed, right? So what will the user see? They will see probably a 500 or some response because the service has crashed now. They won't get a 400. So they will think that this transaction has not happened, which is true because we have not persisted that state, right? So it was only in memory. We never persisted it. So that should still be okay. They will have to retry, but we didn't debit or we didn't credit in reality until we save.
So what about the verification logic in the database layer? Because as let's say I'm sending 1,000 rupees from account 1 to account 2, the debit should happen and the credit would happen in the second account. The credit will happen in second account. So once the amount which is coming in and the debiting and the balance check and everything, so all those data, whether it is saved properly or not, there is a separate logic we'll be doing in DB, right? For saving all the data, whether it's the data are saving in perfectly in expected values. So again, we need to write one more logics in the DB side also, right? In case if you want to know the data is being properly saved, in that case.
No, because the repository method gives you that feedback. When you say save, it returns a Boolean or something which tells you whether save succeeded, right? So you already get that feedback. You will not write anything additional in database layer about whether debit happened, credit happened and all, because then you're kind of leaking again domain logic into infrastructure layer. What database layer or repository layer knows is that it has an object. It does not even know what kind of an object it is. It is just an JPA entity kind of a thing. That database repository class does not have no conception of what is an account. It just sees it as a dumb object and saves it. And it can tell you whether it succeeded in saving it or not. Right? So there is no conception of debit, credit, and all those rules. I mean, you can build it in the database layer. You can write all that, but there is no need for doing that. We can move all of that business related logic into the domain layer. Any retry or application thing, concerns of consistency into the application layer, and keep the database layer as something which we use just for putting objects and getting objects without knowing what kind of objects. We don't need to, repository layer doesn't need to know that. This is just, we are trying to segregate the concerns so that we know where what responsibility lies, ultimately with the intention of managing complexity. Right? If we start not having clear boundaries, then we'll end up having all logic, all places, which will eventually become difficult to manage. That is why the pattern.
Domains which is not suitable for layered architecture, this kind of architecture.
It is possible. A layered architecture is recommended for heavy duty applications. If you are doing some simple, oh, that's a very good question. Layered architecture is not recommended if you are doing like timer app or some small to-do app or things like that. If you are building like an e-commerce application or something like a Swiggy kind of a thing, so those are complex applications. That is where domain layered architecture is more suitable. If you are implementing, say, a software for a library to manage books, that is going to stay local. Not much complexity in that. So no need of layered architecture there. Only if the complexity, if you think that the complexity is going to be big and you have to support the software for a long time and it has to evolve as business changes, that is when layered architecture makes sense. And then because you have to manage it for that much time, right?
In that case, I have a follow-up question. So we are discussing about there is a hexagonal architecture as well. Maybe this is we are talking only with the layered architecture, but do you see hexagonal architecture as an extension of the layered architecture? How you see as hexagonal architecture?
Hexagonal architecture is a slight variation of this in the sense, see, all the architecture that are alternatives to this pattern do advocate having a separate domain layer. That everybody is clear about. Hexagonal architecture also says that. In that, they are similar. But then the other aspects of it, right? How they handle infrastructure concerns or how they handle presentation concerns, that implementation differs. So they are alternatives with some similarity and some differences.
Yeah, because the adapters part, right? Adapters port,
Exactly.
ports parts, it's different. And the one thing I can see the difference is the domain is entirely independent here, right? And in hexagonal architecture, its domain is kind of can able to communicate with the infrastructure as well. And the one different part is the ports, the where the like, application, right? Application can able to communicate to the domain, and domain is full take full responsibility from that. So that's why, because that seems to be very maintainable, because we recently implemented that, and we moved from layered architecture to hexagonal architecture.
Okay, so you are saying the application, so here also application layer delegates to domain layer. I think in hexagonal architecture it does. So what was the other benefit you saw that prompted you to?
Exactly, right? So here, the layer architecture, you are having a one application layer, right? And in hexagonal, the domain is entirely dependent. So if you're going to have another application, right, two applications trying to use the same domain, you still can able to do that, but you need to have another infrastructure layer, or because to have your domain same, but the application and infra might be different.
Correct.
Right? This I think this is the model hexagonal is trying to implement.
Right.
The port is nothing but a different entry point, and adapter is nothing but a different way of converting the data from application to the persistent layers. So this is how the things are.
Yeah, that makes sense. Yes. Yeah, so there are alternative patterns as well. We are discussing one pattern. I will briefly mention the alternative patterns also. But any questions so far? Yes.
Yeah. In this example, it's only one domain object is performing a business operation, right? Consider if I need some other information from some other domain to execute my business. In that case, there need a interaction between two domain objects, right? In that case, do I need to come back to another layer to get that information, or is that okay to interact between two domain objects?
A very good question. So here maybe you have all this information self-contained, but imagine if, hypothetical example, say minimum balance was to be fetched from some other source, maybe as from an external source. Hypothetical example, I'm splitting the domain just for demonstration. If this application, this transaction service that we have, if it had to make an API call to get the minimum balance information, that will happen from application layer, right? Because that knows whom to call, communicating with other services, communicating with databases, communicating with persistence and all is application layer responsibility. It will get that. Once it gets that, it will pass that information to the domain layer again. Just plug it in and then let the domain layer do whatever it needs to do and return the final result for the domain rule, which is do the debit credit balance and ensure both succeeded.
Consider I'm having a user profile which is there in the same database, right? I'm setting a maximum seal value for any debit is say so and so amount. Before debiting that amount, I have to check my user profile and see whether it is below that limit, and I have to proceed with the transaction. Right here, that profile information is there in the another table, which is managed by a different domain object. So here it is not an external system in this example. Same system, same database, right? So two different domain objects. In that case, how that interaction has to...
Domain objects can talk to each other. So objects in the same layer can talk to each other. There is no restrictions on that, right? We said rule number 1, objects in one layer can talk to classes in below layers or same layer. That is okay. Only the lower layer cannot have a direct dependency on higher layer. Like they cannot hold a reference and directly call methods in higher layer. Same layer is fine.
Okay, so in that case here, we have to go for another query to get the profile information and it has to execute. Okay.
So application layer will get the user object from the repository, infrastructure layer. Now it has the domain object, user object. And then you can pass that into the domain layer, right? In the fund transfer service, you can pass the user object. And then that can fetch the balance and then go on performing the check of whether the debit can happen or not.
Okay.
Right. So we would not pass the user object into the account object. So technically, like we don't pass around entities into each other for performing operations. So that is why we have this fund transfer service, which can work with two fund transfer service in the domain layer, which can then work with the user object and the account object to complete the transaction. We will not pass one account into another account. We will not pass one user into another account. So those kind of entities we don't pass into each other for performing logic, which is based on each other's state.
Okay.
Right? We'll technically keep this in the domain layer service. We'll create a new service in the domain layer, and that will orchestrate between the two entities. Right? Whereas whatever is within the entity, whatever state is there, if we want to expose a behavior on top of that, like we saw account active status. So the active attribute is there in the account object itself. So it can tell whether it is active or not. It can tell when was the last transaction, last updated. All of that information is within the account. So it can give all that information to anybody who needs. But it will not go look into another account. Like you will not pass account 2 into account 1 and then say check whether account 2 is active. That looks like we are mixing up entities, right? Giving too much responsibility to an entity beyond its own existence, right? Make sense? Many questions. Why two services? But in this flow diagram, only the transaction layer ensures actions of debit and credit are succeeded, because transaction layer only has to call the rollback flow, right? Yeah, so that is right. The transaction service, yes. So we have a transaction service which performs the database operation of saving both the updated account objects. Yeah, that is correct. So whoever asked that question, that is right. Why two services? That I explained a bit in detail. Maybe you can go back and check. I explained why we need another fund transfer service, because otherwise you would end up leaking one rule, business rule, into the application layer, which is both debit and credit should succeed for the transaction to be complete. So if you watch this again, whoever has asked, you might get the answer. In the interest of time, I am moving forward. Are the layers tightly coupled? If so, what flexibility would this layering flexibility allow for deploy ownership? So the communication rules that we defined during the earlier part of the presentation, it uh, allows for reducing the coupling. So those communication rules basically are mechanisms to reduce coupling. You can again go back and listen to the earlier parts of the presentation. Layered architecture pattern equal to clean architecture equal to domain centric. Clean architecture is another pattern. So when we will talk about alternatives, alternative patterns to the layered architecture pattern in one subsequent slide. So that will be answered then. When we transfer from account A to account B 100 rupees in the domain layer, it validates if account A has 100. So it detects and credits to account B. But by the time it reaches the infra layer in real world at high volume transactions, some other request would have debited that amount, and now account A is now zero balance. So this will eventually fall in infra layer. So now we need again to handle. So application layer will have to manage some amount of concurrency. Yes. So whoever asked that question is a good question. Managing concurrency will be a concern the application layer will handle. Again, because see, when you are in physical world, there is no concept of software concurrency, right? When it will be a queue, means people will come, they will do one by one, transactions will happen. This problem happens because we are now implemented that domain into software. Concurrency becomes a concern of the software. That will go into application layer. I hope that distinction is clear, Sriram. So all the questions are answered. I'll move forward. I think we are almost there, but good questions. Thank you everyone for participating. We are just moving towards the last game. This is my repo. If you want to go, this is the public repo. You can search for Sayeed Hussain on GitHub and go to this repo, see the code for yourself. So now that we have some theoretical understanding and we also have looked at the code, we'll play a game to identify the layers. I hope this comes on. So this game is called Identify the Layer. So we understood the layer architecture. Now we will see each scenario. We'll look at different scenarios and then identify the layer in which this particular code, this particular concern should reside. Sending SMS of credit or debit. Anybody wants to guess where this concern should be? Okay, infrastructure one. Domain another. Just credit. Okay. So we have 3 answers. This is an application layer concern, right? Let me quickly explain why. So the credit and debit has happened, the transaction has happened. Now, if you look at the you saw the use case that we looked at earlier, where we have to notify a user when they are eligible for a new credit card. So that whole use case was orchestrated by the application layer. And whether the user is eligible for the new credit card was a domain layer concern, and how to notify the user, sending email or email notification, push notification, SMS notification, those capabilities were there in infrastructure layer, but the application layer decided which mechanism to use to notify. So application layer ultimately was the responsible uh, ultimately responsible for performing this action, although it might have leveraged infrastructure layer and domain layer. But the responsibility for this particular action was with the application layer. Say utility for sending SMS. Infrastructure, correct. Checking account balance before withdrawal. Great. Validating user inputted account number. Any responses here? No, presentation. This is presentation. See, you are dealing with user input validation. Checking account active status before doing a debit or credit. This is domain. Yeah, let's see who can answer this. Exporting account transactions to an Excel file. Application 1. Presentation. Okay. Okay. So see, the responsibility is one, right? It can use others. So who will decide? Who is the owner? Okay. So there is no Excel in non-software world.
There is a list of papers in the non-software.
Right.
So that's the Excel in software world.
Okay. So I think somebody mentioned infrastructure, somebody mentioned domain, somebody mentioned presentation. Infrastructure, yes, sir. Go on. Okay. So I think this is an application layer concern. I think what we are confusing is there will be a utility in infrastructure layer to export transactions. That will be there. But this use case of exporting a requirement like this, where you have a use case to say export all user transactions within a date range, etc., that will be handled by the application layer with support from infrastructure layer. Right? There is not much domain itself involved here. You can use the repository layer to get the transactions of the account.
Objects are belongs to domain, right? Whatever you are exporting from infrastructure, you are making it with the domain model. The domain model, something. The objects will be hold something.
Yes, objects will have the transactions list.
These objects are coming from domain.
Domain layer will have a list of transactions. Say account has a list of transactions. Yes.
So account is part of a domain.
Yes.
Transactions also part of a domain.
Yes.
Then we are using this object, which is part of a domain, but in infrastructure.
We are using account, which is having transactions. That is one, right? There is a nested relationship. We are using infrastructure layer also for the Excel functionality, right? So yeah, no, to export it into an Excel will be a utility method in an infrastructure layer, right? And then application will coordinate this. Put it over there, right? So get the details, get the account transactions, get the list of transactions, and then ask the infrastructure layer to export this transaction into Excel. No. Who is doing? Yes. So whoever is doing this whole thing is the owner. So if it is just about a utility for Excel transactions, then you're talking about that utility, right? You're not talking about this functionality. If that was the case, then it would be an infrastructure layer concern. But here we are talking about a functionality of exporting the transactions. We are not talking about just a utility to export transactions to an Excel. So that is the difference. There are some questions, but I don't think we have. Validating user inputted account number, having this in presentation layer will require every other presentation layer to replicate the same account number validation. Shouldn't this be in domain layer? So this is basically like user input validation primarily is a user interface concern. There is a possibility of some duplication in other layers, but in the interest of keeping the responsibilities as per the architecture, some duplication might be inevitable. Getting last transaction of the account. Who wants to, which layer should this belong? Domain layer? Okay, there is a question. Can you ask again?
So in real-time application, we used to have something called DTOs. This helps us to transfer data between multiple layers presentation to application. So in which layer should this DTO be owned?
So DTOs are mostly when you're getting a request from into your controller. Let's say if you're talking about a service which exposes REST endpoints, then you may be getting some request DTO, and you will respond with the DTO. So in our case, if you saw this transaction request, this is a DTO. We just don't have a name DTO in this, but this is a DTO. You are getting it in the as an input parameter to the post endpoint call. So this is a DTO. Depending on where it belongs, the DTO will reside there. So if it is in the controller layer, the DTO will reside there. Say you have a utility to make a network call to some other service, right? That would probably be in infrastructure layer. So you will have a network client, say weather client or whatever. And then the DTO that comes will also be in the infrastructure layer only.
So can I assume DTO is something common to all the layers?
It will. You will not have DTOs in domain layer for sure, and you will not have because domain layer will work with domain objects. It will not work with transfer objects, right? So you will have to at some point convert a DTO into a domain object, right? We have done that here. If you see, this DTO was born in the controller. We had that here. Transaction request. We had that here. But the moment we went into the application layer, we got rid of it. We broke it down. Yeah. So yeah, so definitely you will not have DTOs in domain layer, but they can be in other layers.
Okay.
Right? Domain layer will not have transfer objects.
Got it.
Any other questions? I'll quickly move on to the last. So this is a domain layer concern. Utility for network calls is a infrastructure layer concern. So I'm moving forward in the interest of time. What did we look at today? We are at close. We looked at the layered architecture pattern. We looked at the rules which govern interaction between different layers to reduce coupling. We saw an account transfer example. We saw some code. We had a game. There are some alternative patterns also, which some of that came up during the discussions. We have hexagonal architecture, clean architecture, onion architecture. These are alternatives to what the topic we discussed today. Now, in terms of next steps, right? Whatever we learned today, I hope it was useful. I want to leave you all with one request. So next time when you are coding or reviewing a code, think about which layer should the code belong as per the pattern we saw today. Thank you.